Hi, can you hear me? Right. I am Viswanatha, working at Open ECG, working with migrations that we are doing at Open ECG. Right. So I've taken one of the case study for that we are working on the migrations, having 2,000 stored procedures and 1.5 terabyte of data. Right. So what are the approaches that we have taken to execute this project, and what are the benefits that useful for the team who are working on the migrations, right? That thought it will be helpful for everybody. So thought presenting that in some of the informations that we acquired the knowledge on the post-trace, right? Right. So a little bit information about Open ECG. We are 130 members located at headquartered at East Brunswick. And we have offices in US at Rochester and San Mateo, and Hyderabad and Bangalore. And we are 80 years almost now in the industry, working with all open source applications, right? And our company is supported with community people, supporting for the Postgres, and have got a good leadership who are having the knowledge experienced with the Postgres, with the other databases. And that is helping us towards our migrations of projects, right? And we are partnered with AWS Consulting. Right, so this agenda which I am talking about with respect to the migration. So these are the things that we observed important when we are working on the migrations. Data type, Postgres has got its own specific data types, and Oracle has got its own specific data types. So when we are migrating it, what are the things that need to be considered when you're migrating from source to the Oracle to the Postgres? What are the things that need to be things important when you're working on this, right? When you're migrating the tables, etc. And then how you are mapping those objects. We'll go in detail when we talk about this object mapping. And then what are the things that we need to consider when you're migrating the views? What are the things that you're not supposed to do, right? That I'm trying to cover there in the views. And in functions, there is various kind of flavors that you have in Postgres. What are the type of functions that we have, and which one were useful for us when you're migrating it, and how it is going to play a role in terms of performance. And you need to understand, you need to sit with the client, and what are the things that you need to consider with the customers and when you're working on these migrations. So it gives more inputs when you're trying to migrate the functions, right? And then the most key part is the data migration. So we have explored a couple of tools in terms of data migrations. So whatever the tools that we explored and how we succeeded, I would like to share that information as well to the audience here. Right? And the unit testing, that's another key feature, which when we are migrating it, how will you make sure our system is same as the source system? That is very important when you are migrating it to the customer, right? So that's another key area which I would like to share what Open ECG does with respect to unit testing. And then comes to the execution, how you are executing the project. What are the things need to be considered when you are trying to execute, when you are executing your project from the beginning to the go live state. Right? That's our thought process I'm going to share there in terms of execution. And some workaround functions, what we identified when we are migrating it, and what are those workaround functions directly that you can use it, so that will be helpful when you're working on the migrating queries and other procedures. Right? So what is important of the data types? Why we need to consider what is the important role that they are playing it, right? So if you look at Oracle, these are the key data types that we generally observe. You take any table, you will have a number, where chars, and date, clubs, and blobs. These are the key data types that we find in any of the Oracle specific databases that we look at it, right? And how we consider these data types in the Postgres. Because Postgres is having n number of 50 plus data types. So which one we need to consider? What is the right data type? How it is going to impact your system? How it is going to perform at your target system, right? What are the things that we need to consider? So we did some analysis around it with our experienced team, and in terms of numeric data types, Postgres, we identified there are 6 data types at the top level that we need to think about. Small int, integer, and big int, and numeric. If you look at any tools that we see in the market, all numbers directly migrated to the numeric, right? So if you consider every way, and so I'll go to that one, that topic next. So at a higher level, these 3 integer types, which are having, they store the information without a precision, small int, integer, and big int. And number is when you are trying to store the data with the precisions. That's when we consider the numeric data type. And the other 2 data types that we have are real and double precision as well. Those 2 as well, we can use it for when you're trying to store with the precisions. But what is the difference between a numeric data type and the real and double precisions, right? So these are some of the things that we need to look at it when you're trying to store the data in your tables. So when to consider small int, when to consider an integer, when to consider a big int, or when to consider double precision float and numeric, right? It's a very key thing that you need to look at it when you're migration. Because the schema migration tools that are available in the market, they convert everything to the numeric data types, which is going to increase size of your database, right? It almost is going to increase 10 to 12, 15%, and your performance also degrade with 10 to 15%. So you need to think about it when you're converting the data types. So that's one key thing that we observe. What is the right data type that we need to identify? So if you look at it, any lookup tables, try to find what could be the size of it, and try to configure them as a small ints, right? And then integer, based on the size of your data, either integer or a big int. One of them, then you can consider it, right? And double precision and float. These are the 2 data types. They do rounding it. When you're doing a financial or a like share market kind of thing, the size, if you are doing a rounding of your precision values, then you will have problem with the size, with the values, because there will be huge differences when you're doing a rounding. So you need to think what kind of application that you're trying to migrate, and what could be the sizes of those data types. If you think that its size required enough to store exactly the values, then you better go for precision, numeric, right? It can store any size, right? If you just think it's just normal values, you can go for a double precision or float. But double precision, little higher, which can store up to 13 precisions, but it's better when you're doing a calculations, there is a possibility of rounding it. So it's always good to go for numeric in those cases, right? And then the other data types that we look at it are the CLOB and varchars, right? CLOB is straightforward to the Postgres, only the text data type that it supports with that size, right? And varchars, one thing that you need to look at it, is it a char? If you're specifying a fixed size, then you better specify as a varchar or varchar of n, because Postgres will not add any space at the end of the one string. If it is a fixed length, trailing spaces, it will not get added. And if it gets added with trailing spaces, it's going to impact on the performance when you're trying to retrieve the data. So you better leave it as a varchar or varchar of n. Varchar of n will not add any trailing spaces, right? That's one thing that we need to keep it in mind when you are specifying the size of your data types, right? And date in Oracle, if you specify only date, it still stores the timestamp value as well. So you need to check with your customers, is it a directly date or is it timestamp on it? Is it required to store the timestamp as well in that? Because if you just query as a system date, you think it is only the date value, but internally it stores along with the timestamps. So you need to make sure with your customer, you need to check what values that it's supposed to store. And based on that, you need to give the right data type. Right? So these are some key things that we observe. Yeah. They both are the same. Character internally, it does the same thing. Varchar and varchar of n, character varying, the internally everything is same. You can specify either one of them. Right? So these are the key data types that we identified that one has to keep it in mind when you're migrating it. And then when you're migrating it, there will be hundreds of tables in your database. How do we migrate these hundreds of tables? If one has to sit and start writing a create table, it takes almost a month's time to get all these tables into the target system with the indexes that you have to write manually, with the create tables, with the comments that each table columns are having it. So how should we go about it, right? So what Open ECG came out is with a solution. We came out with a schema conversion tool that we internally developed at Open ECG. So any project that we start migrating it, with this tool, we start migrating the migration project in first 1 hour itself. In the first 1 hour itself, right? So you not to wait, the team need not have to wait for next 1 month to once all the tables are get created and then start working on the migration. So first 1 hour, everything is done. We have all the schema tables ready. The team can start working on the migrations of functions, procedures, and other stuff, right? So what we do with this tool? So we configure all our all the mappings which we just discussed, the source to the target. What is the mapping that we are trying to do it? That mapping that we specify. So our tool is intelligent enough to understand what is the size. Is it number with any specific precisions that's specified or not? All those things it will verify our tool, and then our tool converts table scripts to the Postgres specific tables, right? So our schema migration tool creates the SQL files for each one of them: tables, indexes, constraints, comments, custom data types, sequences, and then it generates a comparison report. So when you generate, how will you make sure what is my source, what is my source data types, and how it is converted? You cannot go and check each and every table, what is my source and target data types, and what are the default values that been assigned, how it is got converted, right? So our schema conversion tool will take care of all that stuff and generates this SQL file for each one of them. So tables separate SQL file, indexes separate SQL file, right? Separate SQL files individually it creates. You just create a database and run them in one go. All the tables and scripts, everything will be ready for you. Yeah. Packages we do manually. Schemas. Yeah, I'll come into the next slide. Right? And this our tool, it generates all this, the files, individual SQL files, and then it generates a comparison report like this, right? So here you have the column names that we specify source and target, and tells that which one of them are matching, which one of them not matching, right? So here, whatever n values, it says that it's not getting matched because it is different data types to the system. Right? So that's the reason you can see, this can be useful for the end customer. He knows what are the differences that are there when you migrate it to the source, from source to the target system. So this will help him what things that got changed, right? So this is what object mapping. So this is where your questions are. So synonyms will be either tables directly mapped to the tables. Synonyms can be defined as views, or you can access them using a set search path, right? And schemas the packages will be into respective schema names, so that your application will be still intact because you are still using the same schema name. So in our application, you might be using the package.functions. So it still remains the same because we are still using the same package name as a schema name. This is nothing to do with the big SQL. I mean, this is a conversion, how you map it when you, when you are migrating from Oracle to the Postgres, right? How you would convert, how the packages, where does it go and stand with respect to the Postgres? So where will that fit? Or both packages, where it's going to fit it with respect to the Postgres? Does it answer your question? Yeah. Next.
Just also talk about Oracle PG and SCP.
That I will talk. That initial I talked about. Yeah, sorry.
What about triggers?
Sorry?
Triggers.
Triggers are some triggers in the Postgres. You can directly map it. Sorry, I forgot to mention it here. Yeah, triggers, it's the same triggers in Postgres. You can map it. You can write the functions and whatever the trigger that you are specifying to the respective tables before and after, it's the same thing. Right? So views. So when we try to convert the views from Oracle to Postgres, Oracle is sufficient enough to have, if it is having a nested function calls within it, and if you're doing a lot of calculations, it still performs well. Postgres, if you are having too many function calls in it, the performance will have an impact on it, right? And predicates, if you are having a window functions within the views, then your predicates will not get pushed into it. So your index scans may not be applied. So it will go for sequential scans and it may take more time for performance. You may see performance issues there, right? And the another feature that we observe with Oracle and Postgres when we compare, right? Oracle having a performance, Oracle has got intelligent enough to access only the specific columns that you're trying to access it. Whereas in Postgres, it does all the columns, whatever that you specify. Though if it is having a 12 columns, 20 columns, right, and you're selecting only 4 columns, still it requires all the 20 columns to retrieve and give you result of the 4 columns. So Oracle it only just returns those specific 4 columns and gives the results. So that way, Oracle is having a better feature in terms of views.
So do we have a virtualized views in Postgres?
Yes, we have the material views.
So that can be also migrated with this tool?
Yeah, we can do that too. And the nested views. It's the same. If you start having a nested views, then also we see the performance issues with the views. Right? And then comes to the functions. So there are various flavors in the functions with respect to the Postgres. So you need to understand what type of function flavor that you need to use it when you're in Oracle. You have procedures and functions. In Postgres 9.4, 9.5, you don't have the procedures. You have only the functions. So how are you going to convert them? So that by default, all the functions are volatile in Postgres. Right? So you need to understand what is the difference between this volatile and what are the other types of functions that we have. So that majorly 3 types of functions that we have started looking at. One is immutable, stable, and the third one, the volatile, the default one. Right? So the immutable, when you need to give an immutable function. So immutable functions are the ones where you will not be able to, you are not supposed to do any changes in the system. If anytime you run, if consistently it is giving the same result sets or any n number of times, it is called an immutable, and it directly fetches you the data from the cache, not from the physical disk. So the performance would be increased almost 75% when you are going for an immutable function. So you need to understand what is when you are supposed to give an immutable function. Is it consistently you need to have the same value from the functions, then you go for an immutable. But it's not advisable to have a select statements in an immutable. Something like a constant that you need, instead of defining a constant, you specify in a function, make it as an immutable. So every time it gives the same result. And when query plan is created, it directly places the respective value instead of function call. So that's how the performance will get improved, right? On the immutable functions. Stable works similar to the immutable, but you can have in a select statements as well. It's kind of a lookup tables where you can specify the select statements, because they very rarely go and change the values in the lookup tables. So stable will always try to go, fetch the same data, because in a transaction, the values will not get changed. So when you execute the query, only first time it will get executed, and next time onwards, it just gets you the same results. And because the value is not getting changed, every time it's not going to the physical table and trying to retrieve the data, the performance is increased by 15% with the stable function time. Right? One of them is, example is current timestamp. If you put it in a begin and end block, and you do any number of select current timestamp, it will give you the same value. It will not change. Right? So you need to think about what functions should go under stable. Like in views, if you're having too many function calls, what type of function calls are these? If they are volatile functions, then they are not performance effective. They won't do any performance improvement, because volatile itself is a data changes. They are not a fixed data types, right? So views, if you're going a function calls, which is required for you, then you better define them as stable functions, so that way your performance will get improved. Right? Volatile. Volatile functions, you can write all updates, inserts, everything. You can do all the data changes with respect to the volatile functions, right? And they are not optimized. They are not optimized. So it takes whatever the time that required when you are executing these functions. And then, any questions here? Moving to the data type, data migrations. Yeah.
We have like data models. So is it means like that sort of the tool replicate the data model doing the mapping, and we generate EDL.
Yeah, we specify in the configuration, we specify what are the data types. So based on the data type configuration, the tool will convert.
Data model itself, we have the data types in our Oracle.
Right.
We have a data model, right? And the data model is same converted into that Postgres.
Right.
And that sort of EDLs we can implement.
Right. Right.
So the tool did like that, or means like there is sort of other way of.
So tool actually, it tries to get the data from your Oracle metadata. It tries to gather the information, what data types that are defined for your in the Oracle for your tables, identifies what those data types, what are the precisions, what are the different values that you have specified when you're declaring it, right? It does that analysis and converts them into the Postgres specific DDL statements. Is that answers your question? Yeah. So, okay. Is that answers? Okay, thank you. So, what are the how we did the data migration? So, what are the approaches that we do? So, we explored basically 3 tools. One is Pentaho ETL tool that we explored, how to migrate the data, and then foreign data wrapper from the Postgres, and then Orato PG, right? Even Orato PG is a complete schema conversion tool which you can use it, but we haven't used for the tables conversion and table conversions, because everything is converting into numeric. So as initially I told you, right, some of the tools which are available in the market, like AWS or Orato PG, so it converts everything to the numeric. So your system itself, the size of the database itself is going to increase by 10 to 15%. The performance is going to down by 15 to 20%.
So can you modify that to
Orato PG? No. I mean, I haven't tried that one. So we came out with our own tool of doing this one. So
We can go in and manually change. Those numerics are converted to.
Yeah, that's
maybe maybe possible to change because it's written everything in the Perl. So maybe source code is available. We can go and do this. We can. Right. So I mean, you can change it. Only thing is you need to understand how the precisions, where the data is getting stored, and how it is trying to fetch the data from the Oracle. And when it is trying to create the respective post-STDL statements, how that mapping it is doing it. If somebody is good at Perl, they can immediately do it. Right. So whenever we do the data migration, so these are the three things which we are not, two things that we are not supposed to is no indexes, no constraints. The moment you start creating them, your data migration is going for it. It's going to increase the time like anything because every record has to be indexed and then constraints need to be applied. So it takes time. So better when you're doing going for a data migration, just hold these two things. First you do the data migration and then apply the indexes and constraints. So you should have only the plain tables and comments. Right? So ETL tool, I'm not sure how many of you are having information. It's just a UI graphical interface tool where you just, everything is inbuilt. You just get the required objects, map it, and then map the source database and target database, and you just execute it. It does everything for you. We need not to specify what, select any insert statements. It does everything for you. But in our case, you have hundreds of tables. How we need to migrate this? I cannot create hundreds of migration ETL, this graphical objects and start migrating it. So there should be some mechanism where I should be able to gather that information dynamically, source to target, it should map it and do for me, right? With one graphical interface by adding one conversion. So how should I do that? So what we did for that one is we created a configuration. The first step that we took is how we need to make divide into multiple chunks, because a table can have a million records or 100 million records. I cannot migrate all 100 million records in one go. There should be a mechanism. I need to make it into small chunks, and the small chunks I can be, because if a chunk fails, everything gets rolled back. So again, I have to do from the scratch. So I need to find a mechanism where each small chunks slowly migrated everything, and my data will be inconsistent on my target system, right? So what we did is, first step that we took is we identified what columns that I can use it to make my data into multiple chunks. A primary column or a column with a date where I can do group by a date column or some other multiple columns, and how many chunks, that small chunks that I can make it. Like each chunk could be 10 lakh records or 1 million records, and make it as multiple chunks of that and execute each chunk as a migration, pulling the data from Oracle to the Postgres, right? So for that, we came out with a configuration table. We created a table where we specify the schema name, the table name, and what are your the columns that you are specifying it for applying the where clause, right? The column names and what would be the column value for it and what would be the operator. So every time at the runtime, it identifies what columns that I need to consider for migrating it, for pulling the data from source system and push it to the target system. So these columns will, based on these columns, the Pentaho tool, what it does is it identifies all those columns based on the configuration, and so the configuration table get loaded, and another status column that we specified here, right? Where is it? Status column, we have one thing here. So one of okay, yes, somewhere, right? So that status column, it checks here if it is already migrated or not, right? If it is not migrated, then it pushes the data into the target system. If in case, because this is a configuration, all the chunks, it takes one by one with a multiple. This is like, you can specify how many threads that you wanted to run in one go based on your system configuration. If your system is a multi-core system, you can specify 10 threads run at a time, and all the 10 tables can be pushed at one go, with each chunk that it is taken from the configuration table and pushed to the Postgres database, right? So it identifies here, if that is already that chunk is not migrated, then it pushes the data, loads the data and pushes to the target system. But in case if any chunk failed, how will you make sure that chunk to retransmit that information? So that's where we identify with the status value. If that specific status value is not set after completing here we are setting that value is done. If it is not done, then when you rerun the chunk, it checks. If it is already set the status as in progress, what we do is we delete the rows because the data will be inconsistent. Because if it is trying to pushing a 10 lakh records and after 10K records, suppose it got failed. So those 10K records, first we need to take it out from the system and redo the complete migration, complete that small chunk, rerun that complete small chunk. So what we are doing is we're trying to delete that chunk here and then running the process again. So that way the complete data can be migrated in the complete cycle, right? So, sorry? Because ETL tool will have a commit, you will have a commit size, right? So if you specify a commit size after that, say suppose 10,000 records you specified a commit. After that, if it is between 10 to 12, 20, if it is get failed, those 0 to 10,000, you need to take it out and then again rerun the script. Right, ID to ID, but that ID number of records would be any number, right? It cannot be just 10,000. It can be a 1 million records. Right, because with the ETL tool, you have a commit with how many, maximum says that you can specify is the 10,000 records with this Pentaho tool. So every 10,000 records, it issues a commit, right? So if after inserting a 1 lakh records, if it gets failed, I cannot read, if you rerun, again those 1 lakh records will come into the system. Your data will become inconsistent. So first I need to take out those 1 lakh records and then rerun the chunk. Because I have my configuration table knows it, how to delete it. My configuration table, I specified what is that chunk, how to identify that chunk. So the chunk, that 1 lakh records will be taken out and rerun that code. No. That one after the data migration. Right now I'm in the data migration. Yes. Before you're doing a data migration, first you do the you should have only plain tables. You do the data migration and then apply the constraints and.
Who is responsible for removing all this index and foreign key relations which is already there in the schema?
So that is, you're talking about with incremental data. That's a different. When, right.
In that schema itself, indexes and foreign key relations are
not created.
not there.
Not there. It's the first time when you're doing a fresh migration. First time when you're doing a data migration, it's not.
But in the source system, there are indexes and foreign key relations. And we should know that what are the foreign key relations, what are the indexes which is to be recreated.
Yeah.
That list who is maintaining? Because in the source system it is there.
Right.
In the target system we have created.
You mean who is the responsible person for that?
No. System. When we using a tool, the tool should manage those things also, isn't it?
Agreed. But with this tool, we used only for data migration. It is not for the complete schema creation and creating the index.
No, first you explained about the schema creation.
Right.
The index and constraint script is available. It will be executed.
You have only the .sql files ready. After this one, you have to run those files.
Yes, that I know. But think that SQL file should be made first, isn't it?
Yeah. That's what. Let me show you.
It's made and kept separated. Yeah. That point I want to clarify.
Yeah, here. Right here, you have all the individual files that's created with the tool. You have all individual .sql files in place. It's kept ready. The moment you are done with the data migration, you can start running all that stuff. Okay. So that's how the data identification will be done.
Please use mic.
Single record fails, you're gonna throw away the entire migration and redo this?
That's a small chunk. Only that chunk will be rerun,
Okay.
not the entire database.
I see, okay. Thanks.
So it's a cut paste operation?
This was not successful actually.
So it's a cut paste operation or it's a copy paste operation? This
It's
activity.
copy
Okay.
paste. It's not a copy command that executes with
No,
respect
I'm
to
just
Postgres,
in
but yeah.
terms I'm.
Yeah, that's right. It's like it executes like an insert into statement, right? It works like an insert into statement. Like you select insert into select from tables. That's the kind of work that
So
it does.
whatever the valid records are there, those will be get copied to the target
Target.
side, and whatever those which are not valid, which are not satisfying the condition, those will be.
What condition? You mean to constraints?
No, not constraints. I'm talking in terms of data types or kind of thing. Like
That's the reason initially we are doing that exercise. So you will not you will not have any issues here.
okay.
That exercise we do in the beginning itself.
Right. Thank you.
Right? Yeah. So this way multiple threads can be at a time. You can set configure and run all the multiple tables can be configured and run the execution in the single go. Right? So the second one that we tried is just want to let you know is like the performance was very slow with this because it's only 10,000 records. Every commit it is doing it. If there are billions of records, then obviously this will not work because it's too much of time consuming. Right? You have any question? Multiple tables.
It's a multiple tables.
Multiple tables.
Okay, suppose the one table contains millions of records, so it will, one thread will handle that one?
It will take from the configuration table, the one which I showed you earlier. The configuration table, it chunks those configurations from for all the tables information, and then at the runtime, it identifies them. This configuration table, it will be used.
My question is that suppose you are forking that dot job, right? This is a per tables, correct? Suppose I have the multiple tables, but one table's volumes are very, very heavy. It's millions of records there, but others are empty, mostly. So in that case, the one thread is handling that all migrations of that millions records, or is doing the multi-threaded within the tables or not?
So if you have all of them, one table with million records,
Yes.
and other tables are 0. So this 1 million, because it is a one chunk that you specified as a one chunk, it's a one thread. It will not split it.
Okay, 1 million records is
In a
comes
one
to
thread.
one chunk.
One chunk. So you have to see how your chunk to be. If you make it as a small chunks, it will be useful for you. If you make it one chunk, if it gets failed, you have to rerun everything. After 50 million, if it is failed, either a network issue or a database connectivity failed, something. If you land into some issue, right, you need to start from the beginning again.
Let me rephrase this question. What you were saying is if there is a single table that is containing a large volume of the data, is it possible to run multiple threads and
Right,
chunk
you can
that
do it.
out?
You can do it. Because based on the configuration, you make it into multiple chunks, just configure it. And you can do that.
Okay, thank you.
Yeah, thanks. So we used the foreign data typer with the similar approach what we used. The configuration table we defined, and we tried to use the same insert, because the foreign data wrapper as well, it just works as an insert into. So thing is, this one as well, we couldn't succeed because if it is a huge data, it's a performance issue. We couldn't see that data taking too much of time for migrating. Even 10 GB, we observe it takes almost 5 to 6 hours. So we felt these also, we were not successful with the foreign data wrapper, right? Because, I'm not going too much details, maybe time is constrained. Then we used the Orato PG. It has got all the features for the complete schema migration, but we used only for the data migration because of the initial discussion based on data types where it took us, it was not supporting all the features. So that's the reason we used Orato PG for data migration. So the way Orato PG, these are some configurable configuration items which require when you're using Oracle PG, right? The way it works, in a one chunk, it takes a 1 million records. That's a data maximum size limit. So you can specify the limit. If you want a small, similarly, you need to identify this number of chunks in this case as well. Define multiple configuration tables. Each configuration table of different, each configuration table can be of multiple tables or a chunk. Because if it is having a 10 million records or 10 billion records, you can make it into multiple configuration files. And then, based on that, you configure in case if you are selecting a chunk, specifies as a select statement with the chunk value, right? And it migrates all this data directly from in the memory to memory. So the way it works is, it pulls the data from the Oracle, keeps it in a shared memory, it keeps it, and Postgres, it picks the data from the shared memory and pushes the data to the target system. So this one, what we have observed, same, multiple chunks, everything we took the same steps, but the data migration with the four threads itself, we were able to migrate this much of size of the data. We were able to completely migrate 1.5 terabyte data in a 44 core system in just 3 hours. Oracle PG. Right? Sorry? A billion records. There are a couple of tables, 600, some tables have 600, 700 million records. Not billion, in terms of billion, I don't remember. But the size of the system, database itself is a 1.5 terabyte data. 3 hours. And system is ready in 12 hours for the client to go to the production. Yeah, that was successful that we could achieve with this tool. Yeah, with the data types. So that's the first thing that we did, a good exercise, identifying the right data types. That helped us a lot in terms of performance, in terms of the size of the data on the Postgres side, because the size as well, it is getting decreased. And another thing that I want to specify here, the RAM itself is a 500 GB, and they have 44 core system. So at a stretch, I could run 30 threads on the Oracle, 10 threads on the Postgres. So 30 threads pulling it, 10 threads writing on the Postgres. And
Oracle PG is only used to migrate actual data migration, right?
right.
For schema object migration,
we can do it. So data types, you need to check it manually. The functions, the procedures, right? Wherever, if the tool is not able to identify, it writes an error message there. So you need to identify how many such cases. You need to go manually verify those changes, and manually you have to fix it, right? There are a couple of things. Why we haven't taken the automated tool for the procedures or functions is the manual effort as well involved. So if you take a procedure, right, and how do you make sure the converter procedure is 100%? Unless you won't go and understand the code and look at source and target and test it, right? So that's the reason maybe if a 100 lines of procedure, you may be taking it 10%, a minute or 2 minutes you may be getting benefited, but rest of the things you need to manually verify it. So that's the reason we took it a manual approach. Because if it is not able to identify the complex queries, like if you are using a plus operator in a join statement, right, it will not identify them. Right, in a common table expressions, sometimes it is missing. Which?
Table number 3 has only four fields, right? But its per second is 901.
Because multiple threads are running at the same. Which one?
The table number 3.
It could be a cloud data as well, because I combined everything. Cloud data, it is a little slower as compared to the regular tables. So the way you have to manage with the tool, cloud data, you give it to some specific threads, and for other tables, you give it to some other threads. So cloud data, even though it is a little slower, with other threads, like if you look at other records, right, there are 5,000 records getting, here 23,000 records are getting pushed per second. If you look at here, 23K records per second. These 901 could be a blocked CLOB data type columns. That's the reason it would have been slow. So it depends on the size. So you have to do a couple of check what could be the right way in when you're configuring it, and which one should go into which threads. So you need to distinguish that, and you have to kick off the process. Otherwise, it's going to be slow. So that some exercise is required, how to configure CLOB data and non-CLOB columns, tables basically.
Is there a way of fine-grained control on configuring handling of CLOB data in a specific way?
Sorry, didn't get you.
Is there a fine-grained control of handling the CLOB data in a specific way?
There's no straightforward.
So like we can segregate the type of data we can configure.
That is in our control. See, based on, you can configure you can configure the Oracle PG. These are the configurations that you specify here. When you specify the configuration file here, right, the table or the chunk that you are specifying it, right? In the configuration table, you specify your chunk in a separate threads. If you're writing into multiple threads, if you're migrating the data into.
Okay, thanks.
Does it answer your question?
Yeah, thank you.
I think we can talk after.
And then how do you validate your data once you migrate it? What are the steps that you take it? Because at the end of the day, the data migrator has to be exactly as a source system. So a couple of steps that we took it is using aggregate functions on the source and the target system and compare the data, how is there any differences in it, and then extracting the key data from the views and the function return values. So views, if there are multiple views and they might be referring to multiple different various tables. So we try to extract the data from them and compare the results. And if the results are getting matched, we verified, we thought that the data could be the same most of the time, right? Sorry?
Verification of the query, once you have moved the query and the data, the verification is manual because...
So for that, we actually, I'll come to that.
Okay,
I'll just
okay.
come to that, right? So then unit testing. So this is the key part with respect to Oracle when you're doing a migrations. When we migrate all the functions, if there are 2,000 of functions, how will you make sure all these 2,000 functions are exactly the same as, working same as the source system? So what we did is we came out with a test cases concept, and we internally built a tool with which we write for each function to make sure complete code coverage as well, how many control flows. So based on that number of test cases, we have written it. So this tool executes these test cases against both the systems, source and target, whatever the results. That if it is doing some data manipulations, we try to pull the data specific to that, whatever data you are passing to the system. Extract that data and compare. Our tool, what it does is extracts the data into a CSV file. Our tool compares that and tells us whether it is passed or failed. So this is something, it extracts this kind of report for us for all the functions. So for every function, you will have to complete code coverage based on the size of the complexity of the function. 1, 2 depends on the number of the control flows. If it is having multiple control flows, we'll make sure all the control flows covered and all the test cases are covered in that. So in this case, what our tool, what it does is, even in respect to the earlier question, what it does is it runs against the views, extracts the data, and compares with the CSV files, and tells us whether they are in sync or not. Right? So execution. When you are executing the project, make sure what is the independent modules, what is the dependency for them with respect to database. That way you can make your customer as well right from the beginning. So the moment you start delivering it, he can start testing the application from his side, he can see the results, and he can start doing an incremental testing. That way he can be successful and he can see the results from the first deliverable itself. So that is another key factor that we were successful in migrations. Right? And plan for multiple intervals, incremental testing, and cutover plan. So for production, what are the steps? What is the pre-production? What are the things that need to be taken care and during the migration and after my post-production steps? So everything planned, laid out, and that will be shared across the team, the client, who are responsible. Everything will be planned and prepared a document and shared across to all the stakeholders, that so that on the production day everybody is available and go live will be a successful program. Right? This is about the complete migration factory that Open ECG follows. So first we do the assessments here, then we do planning and implementation, UAT, and go live. So it's a continuous process that we do it. And these are the some work around the functions that Oracle to PG when you're converting it. Oracle to Postgres when you're migrating. Some of the functions that we listed out, which may be helpful for the team here, right? Merge conflict, which is there with Oracle. You can use it as with the CT. You can achieve it, and we learn distinct order by is again distinct order by is not available with the Postgres, that you can achieve it with the common table expressions, right? And output line is kind of debugging statements, which you can use it as a raise info in the Postgres, right? I think that's all.
Okay. Any question?
The source database will be offline during migration,
Right.
or
Cut off.
scheduled jobs can be migrated, or
Yeah. No, you cannot. You cannot have that. Because if it is data is getting reflected, changing it, you will have a mismatch with the data. If there is any change happening it on the source system with your scheduled jobs, then it will, you migrated data is getting impacted here. So that will be a problem on the target system.
So one of the most difficulty in migrations are basically migration of stored procedures from Oracle to Postgres. And just wondering, what are your approaches and how you qualify the test coverage or code coverage in order to ensure that you have validated enough in order to hand it over to the customer.
So every function we are making sure that based on the tool that I earlier told you, like we created a test tool and creating coming with a test format. So this test tool, what it does, it executes all these test cases against source and the target and extracts the data. So, and once we extracted that, we start comparing that information.
You have to manually create test.
Test cases are manual because the data will keep changing it, right? So data will not be consistent.
Any other question?
I mean, if the data remains same, you can use the same test case any number of times. Maybe I didn't get you. I'll answer your question.
So both this test tool and the migration tool, is it free to download?
Sorry?
The test tool and the migration tool, is it free to download?
Open ECG tools.
Open ECG. So,
Yep.
but is public can just download it?
Not yet available to the public.
Okay.
Right now we have the Schema migration tool, which converts all the data types and proprietary. Unit testing tool, which we have. So this migration tool that we have, it works for Sybase, SQL Server, and Oracle. Schema migration, schema conversion tool or migration tool.
Excuse me.
Sorry, one second. No, because there is still manual interaction is required, so we haven't gone to that state yet. Because if you look at a function syntactically, the create procedure kind of thing, it may be helpful for you, the template kind of thing. But internal code, when you need to do a unit testing it, you need to understand the code to prepare the unit test cases. So that's the reason I definitely need to spend a time on a function. So that's the reason we haven't gone to that function migration, functions conversion to with the tool. Hardly it is giving me, if I take a template kind of thing, so for a procedure, all the templates, everything ready. Internal code, again, I need to go and verify manually because it may not 100%, it may not convert 100%. There are cases where it will have issues in a plus operator or a merge conflict statements. The tool is not able to convert them.
Please use mic for asking the question.
How the tool will handle the assessment reports? Like it's a manual process or
Assessment?
something? Yeah.
Yeah, one of our people will go to the customer side and do the assessment.
So it's total manual process, or what you used to run any scripts there and check how many tables are, you can you can successfully migrate, how many, some kind of resolutions like workaround exist or something,
No, that we are not giving it because the
So it's
complex.
something manual process, right?
It's a manual process.
Any other question?
Does this tool help in migrating the database links which are existing in the source database, Oracle?
No.
No, right? So that
You mean Oracle PG or is our internal tools?
any tool,
No,
your
it
tool
doesn't.
or
No. You can use a foreign data wrapper to push the data from any database like Oracle or SQL Server to migrate the data. But if it is a huge data, then you'll have it takes too much of time for you.
okay. From your experience, did you face any time such kind of scenario where you had to migrate the database link in the source database? Suppose there are two databases, A and
Right.
B, and from A you have a DB link to B.
Yes, we did that.
And from A, you are trying to insert something on
Right.
Oracle B. So how do we go about this when we move to Postgre?
If you are using from Postgres, use a Postgres FTP foreign data wrapper.
Yeah.
But if you are using something others like the SQL Server, you can create a link there, DB link, and you can use from either side. You can directly access the database.
Okay. So our sequences, can we use a sequence on other database to insert a value on the target database table?
If that sequence value is set properly, and if it is you are accessing instead of passing the value, you are trying to pass the sequence ID itself, then you can do it.
Okay. Otherwise, I can't call I can't generate a sequence there. Correct?
With the foreign data wrapper, you can generate.
Okay, I can
The
generate.
foreign data wrapper is the one which it internally converts the syntax into the target system and executes it. So if you are
Okay.
using Oracle, you are using a foreign data wrapper, you can query anything, you can do everything on the from Postgres to the Oracle system.
To the Oracle database. Okay. Thank you.
Thank you, Viswanatha. It was a really interactive session, and I hope many of us will get some benefit out of this.
Yep.
So if any other
Thank you.
question, you can just talk to him outside.
Yeah,
Thank you.
Thank you.